location, the building that we have, our building, which is 25,000 square foot industrial building, we have a room that's a class 1 div 1. Class 1 div 1 location, so we are required to have explosion proof equipment. Hazardous location, if you work in the manufacturing area, a lot of manufacturing area guys and certain areas of the commercial building will have some type of a gas or a dust or flares that could ignite the surroundings. And when you design a power system or a lighting system or a low voltage system for these locations, you have to take into consideration that what the code requires you to do in these places. The only thing you need to worry about, a branch circuit, guys, continue to be a branch circuit. A feeder continue to be a feeder. It's not a big deal. The only thing is the wiring methods that we use in these classified locations. Great places to do classified location. We as an engineer, we don't get into classifying gas as an electrical engineer. For the most part, hazardous location, you could, but for the most part, we walk into a building, we ask the building the building officials and so forth to classify what classification this area. Based on the classification of this area, we decide what wiring methods we need in this area. So that's the thing that you need to know. A couple of things, guys, I would like to do and look at today as different classes. We'll talk about the different classes based on the NDC code book that we need to do. The divisions. Hazardous location are 3 classes, 2 divisions. We'll talk about the classes and the divisions for each one of them. And also they go by groups. Groups are a big deal, guys, in hazardous location. Group of flammable gases and combustible dusts. Big deal. So that's that. If these group of gases and or dust exist in any building, that will qualify this part of the building or the whole building to be classified as a class 1, 2 location. Intrinsically safe system, for those of you who want to be designed there, you're gonna hear about the term intrinsically safe system. What is an intrinsically safe system or circuits? So you're gonna hear about this one. We have seals in hazardous classified location. As you guys know, you don't want the gas to be channeled through a conduit from point A to point B. Point A be in the hazardous location, point B be somewhere else in or outside the hazardous location. So we need to talk a little bit about hazardous sealing in terms of vertical seals and horizontal seals. Difference between explosion proof. A lot of class 1 div 1 location, you have to have an explosion proof, and another term that they use, enclosed and gasketed luminaires. Enclosed and gasketed luminaires. So these are a few things that we would like to go over, and feel free to stop me at any time, as we have done in the past. Stop, Chad. A couple of other things, guys. Requirement for pendant luminaires. If you have in a hazardous location, you have a pendant luminaire. We would like to talk about the requirement with rigid, how to mount this pendant luminaire. Flexible. Can I use flexible cords in hazardous location? Yes. What are the requirements for using flex in hazardous location? You have a machine in a hazardous location. How are you going to tie this machine? Good luck bringing EMT. Well, you can't bring EMT. Bringing rigid directly to this machine. Every time this machine moves, it's going to vibrate through the whole building via the conduit system. So flexible requirement for flexible and hazardous location. So these are a few things that we're going to do. Okay. The code, guys, classify the hazardous locations based on our system into 3 classifications. These are very important to understand, especially in the industrial. Class 1, Class 2, and Class 3, as you probably by now know. Class 1, the most important thing about Class 1 is the term gas or vapor-produced gas. Gas or vapor-produced gas. Any location that have a flammable gas or explosive gas, that will qualify as a Class 1 location. That's it. Gas or vapor-produced, the vapor that produced out of a liquid vapor produced out of a liquid, the flammable liquid, and the vapor that produced out of that flammable liquid is also classified. It's also gas, basically. Flammable gas, explosive and flammable gas. Any location with a high concentration, the code, guys, I can't emphasize the word high concentration. There are 2 factors, guys. First, you have to have the gas. Second, 3 factors. First, you have to have the gas, the flammable gas. Second, you have to have enough concentration. Well, they have to have the gas. Second, you have to have a flammable gas. Third, you have to have enough concentration in the air to be explosive, right? Or flammable. So that's a major, major part. Is first you have to have the flammable gas. Second, you have to have the concentration. You might have a flammable gas, but not the concentration. That doesn't qualify as a class 1 location. Okay, class 2 location. The word for class 2 location, guys, is the word dust. If you want to highlight dust. Dust. Any combustible dust or flammable dust or explosive dust that you have in any area, flammable, combustible dust in any area, that will qualify as the word. The key word is dust here. Flammable dust, metallic or non-metallic dust that's flammable or combustible. Any area like this will qualify you as a class 2 location. Class 2 location. Class 3 location is fibers. Fibers, grains, and so forth. There's a lot of examples, guys, that you can do. Combustible fibers, so the fiber and the dust kind of overlap a little bit. Sometimes the fiber creates a dust. Fibers, if you have a combustible, a certain concentration of fibers in a certain area, that will qualify as a class 3 location. Now looking at it, which one is the most dangerous hazardous location? Anybody can check? One.
Can you say this is a class 1, class 2 area?
Yes.
Okay.
Yes, very good point. Can I have a gas and a dust in one area? Yep, that's the worst of the worst. Or can I have a lot of areas, guys, especially 2 and 3 overlap a lot. 2 and 3 because you will have a dust and you have fibers flying in the air. Or you can have a gas in the area. So that's, you have to, yes, absolutely. You can have an area classified as 1 and 2. But 1 and 2. Absolutely.
What's the difference between class and division?
Oh, we're coming to the division. So these are the classification. The code, good point. The code, guys, refer to these. This is 500-01, this is 500-02, and this is 500-03. These are the 3 locations where you're going to find these 500-02 and 500-03, the classification of the class 1, class 2, and class 3. So all the information that you need about these, a whole article about each one of them. Any comments, any questions about the classification? 1 being the most dangerous, 3 being the least dangerous, And then you get into we'll talk about that, then you get the class and then you get the division. Class 1, division 1, the hazard exists at all times. So think about, guys, the division. If the hazard exists at all times, that will be division 1. If the hazard for the most part exists under abnormal condition, that will be a class 2. Division 2. Division 1, the hazard exists at all times. Like, imagine a tank, a gasoline tank. Inside the gasoline tank, what do you guys think inside the gasoline tank will be? Class 1, div 1. Surrounding the gasoline tank, there is no gas outside the gasoline tank, right? So the surrounding the gasoline tank, based on the distance and so forth, could be class 1 div 2, because if that tank is to rupture, what are you going to have around it? You're going to have gas under abnormal conditions. So division 1 exists at all times. Division 2 under abnormal conditions for the most part. So that's your classification. So class 1 location. Equipment cannot have exposed surfaces. Most of them, guys, they go by the exposed surface. A lot of big deal, the exposed surface. When you put an equipment in a class 1 location, especially class 1 div 1, you don't want the temperature, the outside temperature of that piece of equipment, switch gear, switchboard, panel board, light. You don't want the outside temperature to exceed the igniting temperature of that gas. Makes sense, right? You have a gas over here, and the temperature of that lens is right above your head. If it exceeds the igniting temperature of that gas or dust or fiber, then you'll create a fire. So the key point is always the equipment that you, especially in a class 1, shall not exceed the operating temperature. The operating temperature shall not be greater than the ignition temperature of the gas. That's it. That's the key point. Because if it exceeds it, if you have a fixture, guys, and the outside temperature exceeded the ignition temperature for the gas, what are you going to get? Explosion. It goes without discussion. So temperature is a big deal when it comes to hazardous location. T, you're gonna hear a lot about T. So in a class 1 temperature, remember, you cannot, the exposed surface, the outside surface cannot be, the temperature cannot exceed the ignition temperature of that equipment. In a class 2 location, that's for the gas. In a class 2 location, they have the same thing. They have equipment cannot exceed temperature-wise what's specified in this table. So they have, in this table, they have a temperature limitation for equipment that you're not supposed to exceed. So they have a table for you. In a class 1, in a class 2 location. So what I want you guys to get out of it, I'll show you a couple of equipments without getting its 5D. Okay, here you go. And if you guys go to page 375, it will tell you the equipment not subject to overloading or normal operation, abnormal operation. They have a temperature for group E, F, and G. And they have a temperature limitation for the equipment in group E, F, and G dust. So, long story short, when you deal with the class 1 and class 2, pay a lot of attention to the temperature, the outside temperature of the equipment when you install it. Outside temperature. Same thing in the class 3 locations. The most important thing when you put a piece of equipment, you have a temperature limitation greater than what's listed in 5035. So they have a table, guys, if you go to 5035, and it will limit the outside temperature to certain values if you are not to ignite the surrounding. So 503. 5035. Okay. And they have a limitation. On the temperature. The equipment is not subject to overloading. Then you have a temperature 248 Fahrenheit for equipment such as motors and so forth. So there is temperature limitation. For a lot of us guys, the most important thing, Ashley and everybody else guys, is when you look at a piece of equipment, without getting into all the temperature, Chris, you have to look at the equipment. The equipment will be listed class 1, div 1, or 2, or 3. So the most important thing when you look at equipment, you're going to say class 1, class 1. If your equipment say class 1, does it want to erase? Okay. Let's see. Class 1, div 1, rated, or
something that's readable from
class 1, you can see it. You can see it from there. Okay, class 1. Let me see if I can get my pointer. I grab my pointer here. Let me see if it's. There you go. So we have this one first, but let me erase this here for a second. Okay, so the only thing you guys need, I'll show you a picture, a nicer picture with you guys. Class 1, div 1, or div 2, if the equipment is rated for this one, or the equipment is a class 2, div 1, or div 2, or the last is going to be a class 3, div 1, or div 2. Okay, so all what you care, I'll show you a couple of equipment, guys. All what you care is about the listing on these equipments. If the equipment has any of these listing, this means, without getting into all the temperature stuff, it's rated for these locations. That's all what you care. This is one of the most important tables that you guys are going to encounter. These are all the gases that make class 1, A, B, C, and D up to this press, all this up to group D. This is your class 1 gases. So for a class 1 location, guys, it's not class 1 and class 2. It's not enough to say class 1. You have to put the group. Is it class 1? Yep. Is what type of a gas? Is it group A, the worst of the worst? So you have to also go by group. Classification of atmosphere. So this is the class from A all the way to D, and it will give you the ignition temperature, the igniting temperature for each one of these gases. So what do you need to remember? You need to remember one little thing. A, B, C, and D go with a class 1 location. And Chris, my friend, if you take these three, what do you guys think? Anybody knows what these E, F, and G goes with which classification? This will be class 2 location. This is one of the most important basically thing about the classification. So when you look at a piece of equipment, Chris, you're going to see that it says a class 1, div 1, group A. It's listed for the gas, group A. And you can read it in page 285. It's group B, all the gases that listed in group B, all the way to group C. You can see, guys, as you go in the groups, the ignition temperature, the igniting temperature for the gases goes up, meaning it's nicer. You know, you need more heat to ignite these gases. So all we care about is when we have in a hazardous location, what group material do you guys have, or what type of gas do you guys have? They tell you what type of gas. Hopefully, you go to this table and you look, is this table, which one of them is which group? It's classified by the Smarter Than Chad people. And you go in group B, then when you look at your equipment, make sure your equipment is a class 1, div 1, group D, or group A. So, Chris, is not enough to have a class 1, div 1. It's not enough, or div 2. You have to also get the group. Same thing for a class 2, guys. It's not enough to say class 1, class 2, div 1, or div 2. You have to also get group E, group F, or group G. So the groups are very, very important. And you can read through these groups. Any questions, guys, about the groups? With a class 1 and a class 2 comes another thing that's called the group. The group is a group of gases or dusts that's similar in their igniting temperature, basically. Similar in their igniting temperature. Yes, Alaribo? The third one does not have a group. Yep. Third one does not have a group.
Now, it doesn't seem to have a temperature relationship. The lowest one is in group C.
The lowest one is in group C.
Yes.
Yeah, group A through A, B, C, D. All what I care is about the classification of the material. You want more information about this one? That's beyond my expertise in terms of a temperature rating of gases. You guys are going to go to the people who deal with gases. So as far as we're concerned, electrical engineers, guys, and designers like yourself, do I have this gas in this group? Yup. Then my material have to say this group. So, and I'm going to leave it at this. For further information, you guys can research it. Contact a couple of equipment. Okay, so that's your equipment. So equipment have to be rated for the location. I'll show you a couple of things that we do. There's something called intrinsically safe circuits, guys. For the most part, the wiring methods that you're going to use for these hazardous location, class 1 and class 2, are threaded, rigid equipment. In class 1, class 2 location, your wiring method is a threaded, rigid equipment. You're going to put in these locations. You're going to seal as you get closer. You saw a couple of seals, guys, that we do as we get into every piece of equipment that have arcing and sparking equipment, as in circuit breakers, motors. You have to seal within 18 inches of this piece of equipment with rigid, threaded wiring system and an approved seal for the location. Intrinsically safe system, these are, you will hear them all the time. Now, don't think, Ashley, you're going to use an intrinsically safe system to power a 50 horsepower motor in a hazardous location. It's not meant for this, guys. Intrinsically safe system meant for a class 1, 2, for class 2 and 3 location control circuits. They use these as a control circuit for the equipment or signaling circuits, sensors, and so forth. So they are all low voltage. Can I get you guys to understand these circuits are low voltage circuits, class 2 and class 3 circuits and signaling circuits, low voltage. So what they do is drain them out of power. They're drained out of power. So long story short, you can grab under normal and abnormal condition. You grab a sensor. You grab the hot and a neutral that's going to that sensor, and you short them. You would not get a spike. You would not get a spike even. So they don't have enough energy to get you a spike, even if you grab the hot and a neutral of that sensor and you short them together. So that's You classify it then. Who cares? When you do them, then if you have this system, then you can install it in a class 1 div 1 locations or class 2 locations. You still have to seal when you put them in conduits. Put them in conduit, you have to seal when you move from one location to another. But that's an easy. They came up. My understanding is they came up with this system, guys, to get you to avoid doing a lot of hard, rigid wiring for a lot of location. Like for example, you can put intrinsically safe system in an EMP conduit, but you can't put a power circuit into an EMP conduit in rigid location. You have to put it in rigid location, in rigid conduit in a class 1 div 1 location. Yes, Oliver?
Yeah, please, I still need to tell me the difference between class 2 and class 3.
Class 2 is the dust. Class 3 is the fibers. It's basically bigger in diameter. So both of them look alike, but the fibers will look bigger materials flying in the air versus very tiny, thin little material in the air. So grain elevators, class 3 location, if you have, it really goes by how the diameter, the code in 2011, they even define it by the diameter. What's the diameter? First, they have to be flammable. Second, they have to be smaller in size to qualify as a dust. So it could be, as I said, 2 and 3 could overlap. But you can have a fibers, a bigger in diameter, then if it's too fine and the smaller in diameter, it becomes a dust. So low power. Okay, so what do? They don't have enough energy, guys, electrical or thermal energy to ignite the surrounding. And Chris, that's all what I care about. Even under overload condition or fault condition. This is one of the most important thing. You guys are not going to be journeymen or masters. This is what they test you on. Intrinsically safe system. Can an intrinsically safe system under fault condition, overload condition, ignite the surrounding? No. Under normal condition, of course, no. Under normal condition. So the other thing, when you put them, you can put them in EMP, but you have to put them in physically separated from all other circuits that are not so considered. So you can, if you have mostly for sensors, mostly for control circuits, guys, you put them in different conduits, EMP conduit. You have to seal the conduit still, and you go to these equipment to sense what's going on. Guys, you have oil refineries. There's tons of these. You think about oil refineries, not just gas stations is a simple thing, but oil refineries and so forth. You have to have a lot of sensing equipment everywhere. Okay, equipment in most locations, especially class 1, div 1, and class 2, guys, you're dealing with rigid conduit and threaded steel and steel or intermediate conduits, or MI cable with an approved fittings. If anybody ever to ask you, Nick, what are the wiring methods in a class 1 or class 2 location? Always say rigid or intermediate threaded equipment, and you're safe in these two classified locations, especially in these two classified locations. If you have anything in a class 1 div 1, the hazard exists at all times. The hazard exists at all times. Then your equipment must be explosion proof. If you guys go to the definition of explosion proof equipment, two things. Number one, it's capable of handling an explosion inside this piece of equipment without the temperature the outside temperature exceeding the igniting temperature of the surrounding. So Chris, the gas can seep into this circuit breaker. You turn the circuit breaker on manually or automatically and make a spark, and you have a big explosion, well, an explosion inside this circuit breaker panel, a circuit breaker box or contactor, and two things could happen. First of all, the integrity of the piece of equipment stays intact; it doesn't explode into pieces. Number two, the temperature, outside temperature, does not exceed the igniting temperature of the surrounding, so it doesn't create another fire around it. So that's a major thing. Now, step number one, what you guys need to avoid, Jackson, my friend, is avoid installing explosion-proof equipment. Very expensive, very bulky. So how do you avoid that one? Avoid putting control equipment and panels and circuit breakers in an explosion-proof location, a class 1 div 1. Unless you have to, then you have to your equipment class 1 div 1. I'll show you a couple of examples of how it looks like in a second. Location must be in a class 2 location. In a class 2 location, dust ignition proof. Dust ignition proof. The equipment, because we have dust, the ignition, dust ignition proof, so it doesn't allow the dust to get inside that piece of equipment. Or interfere with the operation of this piece of equipment. So for dust, you don't want the dust to get in and or interfere with the operation of that piece of equipment. In an explosion-proof equipment, you don't want the gas to, if the gas is to get in, explosion, the surrounding air is not going to be ignited by the temperature, the outside temperature of that piece of equipment. So you're going to hear all the time, explosion-proof in a class 1 div 1 location. Class 1 div 2 location, it depends. Class 1 div 2 location, sometimes you don't have an explosion-proof guys equipment. So be very careful. Explosion-proof is in class 1 div 1 location, mostly. And in a class 1 and a class 2 div 1, dust ignition-proof at all times. Seals. What they do, guys, they have a seal. Seals, the smarter than Chad years ago, Chris. They discovered that. So a couple of things. If you have, can you guys look at this? This is an explosion, a class 1 div 1 location. I have a class 1 div 1. So your motor have to be explosion-proof motor in a class 1 div 1 location once. Now, I have a magnetic controller. I have my magnetic controller. I have a motor, and I do have also, God forbid, a breaker panel. These, can you guys? Everybody can see that these are arcing and sparking equipment. Everybody knows why. Would the motor, when it's running, get a tiny little arc from the bearing or something? Yeah, you could have an arc here, a tiny little arc, not a big arc. With the magnetic contactor, every time you open and close the magnetic contactor, would you get a little arc out of it? A little spark? Yep, that's a spark. How about the circuit breaker? With the circuit breaker under normal or abnormal condition, when it trips, when it interrupts the load, would it bring a little tiny spark? Yes. So that's what they call the arcing and sparking equipment. You need to seal within 18 inches of each one of these equipment. So if you guys can see that one, here's that one within 18 inches, you're going to seal it. This one also, this one, can you guys see the seal? Within all the arcing and sparking equipment, you have to seal. And then when you exit to a non-hazardous location, you have to seal within 10 feet of the point where you exit to a non-hazardous location. Anybody knows why I want to seal here as I move to the other location? Because you don't want to channel the gas from a hazardous location into a non-hazardous location. So the require request as you enter, here's my switch gear here, and I'm bringing this rigid metal conduit here. You're going to seal in either side. You put your seal, now you seal it. If there's any gas, the gas will not be able to seep through the conduit to the non-hazardous location. And then also, going anywhere else around this arcing and sparking equipment, here's my seal around it, perfect. And so the gas can't go to the non-hazardous location, and also the gas can't get into the arcing and sparking equipment. Arcing and sparking equipment.
So it's now the explosion-proof motor. The motors need air.
They go through a whole ventilation for them, external ventilation. Yeah, they get into ventilating to the outside to get the air and the cooling. They have to be rated for explosion proof.
So the whole point of the seals are
to stop that gas from getting into the conduit and channeling itself to the inside of the motor.
So if we were to spray gas, if we were just to spray gas in the conduits, is that what you're talking about?
No, but yes, and or there could be seep in the gas in this area, and the whole area could be full of gas, right? So then exactly sprayed gas over here. It wouldn't go into that area where the spark is. And if it does, gasless material.
Thank you.
Yeah, not gas as in petroleum gas as in gasless material. Now what you're going to do, now if this is to seed, even if this is to seed neck, then you're going to have an explosion proof, and this equipment should be able to handle the explosion proof.
Okay.
the explosion inside the equipment. So that's where we get into the hazardous location. So the seal guys minimize the passage of gas, and we're talking about gaseous material here. They have available in standard conduit sizes that you can buy it, can be installed vertical or horizontal as you looked at them. Designed with a drain. If you're vertical, you have to have a drain plug so you can drain the moisture to avoid moisture inside the conduit, especially if it's vertical. The moisture will condensate, turn into a water. The last thing you want to do is water seeping into your magnetic contactor. The drain seals, they have also drain seal fittings, guys, contain some weep holes, they call them, to permit the continuous draining. You'll see if you go to the manufacturer, guys, they have a little seal here that's continuously allowing the water, if there's any condensation that turn into a water, allows it to continuously seep outside the conduit. Who cares? You don't want to channel that condensation of water into where? Into your equipment. You have an explosion. So here's a couple of seals that you can do. Any comments, guys? Any questions? Any comments? Any questions? Any comments? Any questions? So, explosion-proof equipment. So circuit breakers and panels. If you put your circuit breakers on a panel and any equipment, what do you guys think the equipment, the circuit breaker has to be rated for? Explosion-proof Class 1 Div 1 in a Class 1 location. The enclosure is the area size, breaker, and number of circuits. So all these you have to take into consideration. I'll show you a couple of panels that you can go buy right now if you want to, explosion-proof. Panel suitable for Class 2 areas. If you are to put a panel with the circuit breakers inside it in a Class 2 location, the key word here is dust ignition proof. The key word here is dust ignition proof. Nick, the manufacturer is smarter than us. To make it simple for all of us, you know what they do in the equipment? Right on the equipment, they say this equipment is listed for Class 1 Div 1, Class 1 Div 2, Group A, B, C, and Class 2 Div 1 and 2 Group G, F, and E. One piece of equipment. So here you go. You want to put it in a Class 1 location? Bring it on. I'll show you right now. You want to put it in a Class 2 location? Bring it on. Div 1, Div 2. So they make the manufacturers standardized, guys, on one piece of equipment that you can install in a lot of locations. Yes, sir. Yes, yes, absolutely. Third-party verification. UL is one of them. I'll show you a couple of them. Okay, so that's now goes without discussion, Alaribo. If I have a dust ignition proof equipment, can I put it in an explosion proof location? No. Explosion proof location though, you can for the most part put them in a dust location. In a dust location if they're rated for that particular dust. Again, the manufacturer guys got smarter than us. They rate them for both locations, especially Class 1 and Class 2 location. Almost always the equipment can be used in either Class 1 and Class 2 location. Luminaires. Luminaires, a lot of luminaires. If you have luminaires, guys, in a Class 1 Div 1 have to be explosion proof. Other than Class 1 Div 1, in a Class 1 Div 2, they don't have to be explosion proof. They can be enclosed and cascaded. Enclosed and cascaded. It's basically less expensive than explosion proof. So if it's enclosed and cascaded, one little thing, they are not explosion proof. So if I have vapor tight but not explosion proof. So if I have a Class 1 Div 1, I can't put these luminaires in Class 1 Div 1. But I can put them not permitted in a Class 1 Div 1. No, but look where they can do them. Class 1 Div 2. In a Class 1 Div 2, I can put them. I have a tank of gas right here. I move higher certain area around the gas tank is a Class 1 Div 2. I can put my light above it with a certain height, and that area will be a Class 1 Div 2. I don't have to have an explosion-proof location. Can I get you guys to understand explosion-proof in the Class 1 Div 1 only? If it's enclosed and cascaded in a Class 1 Div 2 location, that's the major part. Hey.
Then the first one, we first since Class 2 Div 1, can we use it?
No, you can't use enclosed and cascaded. In the the project that we have, guys, our project says class 1 div 1, and we give you a piece of equipment that's actually explosion proof light.
I'm gonna try question it says class 2 div 1. Are we using that?
Class 2 div 1, no. No. Not in a class 1 div 1. No. No. If it's class 1 div 1, for the most part, it can be used anywhere else. See, the hazard, the class 1 div 1 is the worst. If it meets the worst, guys, it meets anything else. But do you see what I mean? If you have something that meets the worst scenario, which is class 1 div 1 explosion proof, can I put it anywhere else in these hazardous triangle? Yep. Okay, fluorescent luminaires can also be obtained in a hazardous location for a class 1, permitted in a class 1 as well in a class 2. Class 1 as well in a class 2. So you're going to find, again, back to the manufacturer, guys. The manufacturers standardize. They can have a fixture that says either explosion proof or separate. One explosion proof, that's always separate. Then the other ones, they can say class 1, div 2, class 2, div 1 and 2, class 3, div 1 and 2. Other than explosion proof, they have one that fits everything else, all the other criteria. Temperature rating of luminaires, special luminaires, guys, because they burn electricity. So you need to be able to, for luminaires, you need to be able to maintain the temperature below a certain value. Luminaires intended for use in hazardous location, they have to have a T rated on them, T rated. What's that T rated, Chris? Indicates the maximum operating temperature of the luminaire. So if the maximum operating temperature of the luminaire shall not be higher than the igniting temperature of the gas or the dust. That's, guys, without discussion, right? Operating temperature. And that's what it says. Operating temperature must be kept below the ignition temperature of the surrounding atmosphere, gas or dust. That's the single most important thing for fixtures, the T rating of temperature, the temperature rating for fixtures. Chris, here's how they do them. Here's an example of all the temperature rating. So T1, all the way, they start from T1 into T6. You can see temperature rating for T6 is, let's do Fahrenheit, is 185, meaning the hottest spot on this piece of, in this light cannot exceed 185. So if the igniting temperature is higher than 185, then this fixture can fit in. If it's cascaded, can fit, is okay for this location. Look at this boy, the worst. The igniting temperature, the hottest temperature, operating temperature for this is 842. That's a hot. So that could not be a good option for certain location. Does that make sense? The higher the T, the smaller the maximum operating temperature of that fixture. Based on these, the fixture will qualify the fixture to be, basically to be able to fit in a class 1, 2, or 3 location. Temperature. Luminaires. Luminaires, guys, there are two ways. Luminaires in a class 1, div 1 location, you can do them in two ways. I have my explosion proof. Here's my explosion proof luminaire, right? You try to avoid it. Because explosion proof because of div 1 and of course class 1 div 1, I have to have explosion proof. I have two options. Option number one, guys, to use rigid. You can see this is rigid metal conduit. Then you have to support it. They have to support that one within 12 inches. These are all code, so it doesn't swing. So you have to support it with the brackets. So if you're like Chad, hate conduits and don't like to bend them, and you want to use cable, flexible cord or cables, no problem. You can go ahead and use. You have to have that mesh. Remember that mesh within 12 inches to hold it, and you have to have an explosion box. As always, these are all explosion box and explosion. This explosion proof couplings, and then you can use some type of a cable, explosion proof cable, if it's a or explosion proof cable to tie this piece of equipment instead of rigid metal conduit. So this detail is a big deal, guys, if you're wiring in a class 1 div 1 location. Big deal. For the most part, also in a class 1 div 2 location with flexible couplings, so with a little limitation. Okay, controllers. If you have manual controllers used to And if you have manual control, start stop button, guys, in this refinery. You have a refinery, and you need the people who are working on a refinery push a button to start and stop AC or DC motors. So that's a big deal. So these motor controller can be auto or can be semi-auto, requires pilots and all this good stuff. So long story short, if these control devices are in a class 1 div 1, Chris, what do they need to be? Explosion proof. Other than class 1 div 1, it depends. Other than class 1 div 1, it depends. They don't have, sometimes they don't have to be class at all. Require using pilot magnets, must be contained inside, explosion proof, and I can't emphasize the word, in a class 1 location, when used in a class 1 location. These are arcing and sparking equipment. And so it goes into, why? Because you open and close your arcing and sparking, so you have to contain them in explosion proof. Flexible cords and receptacles. Can I use, guys, cords and receptacles in a classified location? Yep, no problem. If you're using them, they have to be in this location, the cord, and we're talking about cords, they have to be extra hard usage in these locations. If it's in a class 1 Chris, div 1, it has to be explosion proof. Other than class 1 div 1, they can be only extra hard usage. Look at this. I need a grounding equipment, grounding conductor, a separate equipment grounding conductor inside this cable. Be properly connected to terminals with the proper connections and terminations. Support by clamps in a manner that the tension does not transmit into the terminals of the connections. That way you use the mesh so it doesn't transfer the tension of the cord, the weight onto the connections, onto your connections. Okay, so you have to have, so another thing, guys, for the cord, you have to have a seal in your cord to prevent the entrance of flammable gases in a class 1 location, flammable dust in a class 2 location, and entrance of the fibers in a class 3 locations. You have to provide a seal also with the cord. Okay, so that's basically the general idea, guys, about the hazardous location. Then the code talks about, these are class 1, class 2, and class 3. The code talks about certain areas. So I'm going to give you 5 minutes break, and I want to go quick over the garages, commercial garages, and aircraft and gasoline. These are class 1 location, and spray area and dipping area, which is a class 2 location. Should we have 5 minutes? Let's go. So the code after that, guys, and I know I teach the apprenticeship for MA. We spend, guys, 4 classes, 3 hours each, for a total of 12 hours in hazardous location. Just to give you an idea. We're going to cover them in 2 hours. So if we're going too fast, that's okay. This is an introduction. If and when you ever get into the hazardous location area, consult your friend Chad or consult the code. There's a lot of issues that we're moving fast into them. As I said, for our apprenticeship, we run 12 hours of classes about hazardous location. We get into details because those are electricians and they need to know the details of how to wire it. So I'll show you a really manual that you can keep. I'll put it on the network. You can keep it. Really cool to specify being engineers and designers. So let me just go over this if you don't mind me. So commercial garages, guys, aircraft hangars, and gasoline dispensing, gas stations, basically. These are examples of hazardous location class 1. Then we're going to talk about the spray and the dipping process. The NDC code book, guys, take these into, Chris, after they talk about the intrinsically safe system, they go and talk about specific location. For example, 511. I hope mine is going to pick up here. So, for example, 511 is the commercial garages. That will be Article 511. And then you get into aircraft hangars. 514 is this one. 514. These are all articles that, as you know, talking a spray is 516. 516 is the spray area and aircraft. should be somewhere here. If I am an aircraft is 513, 513. So to get the full scope of it, you have to review. I feel sorry for you because we're reviewing 4 articles in an EC code book in less than an hour. So if it's give you the full picture, this is just getting your fingers kind of burned a little bit into the system, and the limit is the sky as you move into this industry if you continue to be in this industry. Great. So that's what I'm going to go, guys. A very few things again. Commercial garages. If you have a commercial garage, and they define, guys, a commercial garage is a garage where the cars can be maintained for like troubleshooting a garage and so forth. And they go into details about the definition of a commercial garage, but think of it as a place where you fix your car and so forth. If you have a commercial garage with any pet, I don't know if they can do pets anymore because of liability. When they fix your car, they don't have a whole lot of pets. Now they left them. If you have a pet, then this pet is classified as a class 1 div 1. These are the places where they work in your garage, in your car. This is the type of the garages that we're talking about here. This area is classified as class 1. Every time you go below the ground in a garage that they work on your vehicle, work on vehicles, this is a commercial garage, and the bottom, anything below the ground is classified as a class, any pet is classified as class 1 div 1. Who cares? Any light in this area, any switch in this area, any sensor in this area have to be explosion-proof equipment, rigid, threaded, explosion-proof equipment with seals. Then the smarter than Ch go 18 inches, and the area immediately in the commercial garage, they classify it as a class 1 div 2. So if you're faced with a commercial garage, here's the smart design to do. You know what they do? Then you have to put your lights at the top here, and you put your equipment in this area. Then these equipment and lights and so forth, with some exceptions, they don't have to be classified. They can be normal EMT wiring methods, because you exceeded you are not in that classified location. You're not in a classified location. So that's what I want to mention about the garages. 18 inches all over the garage is class 1 in every direction, class 1 div 2, and the pits are class 1 div 1. So whatever you install there has to meet these 2 criteria. And I'm not going to go there, guys. Also, you have between you and the office, you have to have a door between you and the office, and they get into how high is the door. Do you have a step to go to the office, step up or step down? So they get into a whole lot of classification. You go to the aircraft hangar. So that's it. The whole article we summarize it by 1 page. Aircraft hangar, guys, same thing. In any area, if you have a pit, this is jet fuel. You have a lot of jet fuel, right? In the other ones, they have gasoline and fuel and so forth. This is class 1 div 1 jet fuel in this area. That pit is class 1 div 1. And what the smarter than Chad guys, they go class 1 div 2, an area of, you can see how to the side of the airplane, 5 feet away from the airplane, all the way up to 5 feet. You can see all the way around the airplane, if you can imagine. 5 feet from the wing, above the wing, and 5 feet around the engine, wherever the engine is located. This area is classified as a class 1 div 2. Who cares? Meaning, guys, when you wire in these areas, move your equipment further away than 5 feet from, you have to almost to clear the airplane. Move it further away, then you get into a slightly different restrictions in this area, as long as you don't get anything in these areas. Does that make sense? So that will give you, and there's a few rules, guys, for wiring above classified areas too. You have to have cascaded equipments and so forth. If you have gasoline dispensing equipment, guys, you have the vent. A couple of places where you can have vent. So you go through. If you look at the dark one, up to 3 feet from the vent where they vent the tank, that's class 1 div 1. And then from 3 to further than 3 all the way to where, Chad? So 3, and then from 3 to 5, I don't know, guys, you see the first circle is class 1 div 1. The second circle around the first one, which is this area, is a class 1 div 2. Class 1. This one is 3, and this one will be another 2 feet. Another 2 feet for a total of 5. That area is class 1 div 1 and 2. So who cares? Avoid this area altogether. Avoid this area altogether. and 18 inches in this area in all direction above this is a class 1 div 2 location too. Class 1 above the tank, class 1 div 2 location. So Nick, the idea of these articles, just to tell you words, if you are in this situation, these are how they classify this area. So when you put your wiring methods, make sure you use rigid, threaded, explosion proof, depending upon the location. Here's where you go fill your car. When you go fill your car, guys, any pit in the area, it's classified as always. Any pit in any location, for the most part, is a class 1 div 1 location in these areas. Now we have gasoline here. This is class 1 div 1. What they do around the gas, 20 feet, guys, in every direction from the pump, 20 feet in every direction, and 18 feet above the ground is classified as class 1 div 2, class 1 div 2, class 1 div 2. 18 feet, 18 inches above, 18 feet from the dispensing, from the gas pump is a class 1 div 2. Also 18 inches around the pump itself. I don't know if you guys can see that. That area here around the pump, this is your class 1 div 2 location. Who cares? Avoid putting anything electrical in this area altogether. Inside the pump itself, if you have the controller and everything else inside the pump, these are listed material, guys. You're dealing with gasoline here and diesel, well, gasoline at this point. So that would be a class 1 div 1 location. So it has to be rated for class 1 div 1 location. So that's your gas station. Okay, so moving on to now the rest. So this is class 1 div 1 and 2 gas location. The rest of it is a class spray area. If you're doing painting, remember when we went to EMI, they were painting in the booth. That painting in the booth could be class 1. Remember, a lot of you said, what's the difference between class 1 and the class 2? A lot of places actually they have them all together. This could be class 1 or class 2 if it has some gases, or it could be class 2 and class 3. So this area, when you are in the booth, interior of the spray booth is classified as a class 1, zone 1, the zone system, and class 2, div 1. So care about class 1, div 1. Forget about the system, the zone for a second. So inside here, there are two classifications. There's a class 1 and class 2, div 1, both of them. Now, when you get outside, guys, in this area, it's classified as a class 1, div 1 and 2 because there's gases and there's dust, flammable gases and dust, and they classify it as a class 1, div 2, class 1, div 2. Based on these distances. So anyway, it goes through, and if you have any opening area with 3 feet of any opening in a class 1 div 2 or class 1 zone 2 or class 2 div 2, these are the two locations. This area here is also class 1 and class 2 div 2 locations around the class 1. So anyway, anything adjacent to a div 1 will be div 2. So who cares? When you put your equipment have to be listed in these locations for these, it has to be listed for these locations. Has to be listed for these locations. Same thing, guys, spray and dipping. If you have a spray and dipping. So we have a class 1 div 1 here in this area because of the gases involved in it. And also this right here, gases, class 1 div 1 location as you dip them and go out. And they have all the dimension. The shaded ones is class 1 div 1, 5 feet, 8 feet away. So that will give you 3 feet here, I believe. 3 feet around this area is a class. So the adjacent area to class 1 is almost always a class 2 location. Who cares? Give you an idea. When we went, this is similar to, do you guys remember when we went to Cummins and they were dipping these panels and all the stuff? They take them to the printer, they dip them, and they move them around, and they keep moving them. That's exactly what they're doing. So luckily, when we get into a plan like this, guys, there's a lot of manufacturing engineers that you sit with. You have a lot of meetings to decide what the boundaries of the classified area. When you decide the boundaries, then we put our electrical system based on the classified location and the boundaries. So that's a nice thing. But for the time being, know that these pictures will help you at least classify certain areas. Same thing for the spray area, guys. If you have the venting for the spray, open spray areas, you can see the first circle up to 5 feet, that's class 1 and class 2 div 1. And the second circle up to 20 feet from that vent area will be class 2. Class 1 and class 2 div 2. Okay, so that's a couple of things, guys, about the classification. Any comments about these spaces? Any comments about these spaces? Did I put you to sleep yet? It's not Monday, huh? Okay, explosion-proof equipment. A couple of things about explosion-proof equipment. This is mostly for electricians, guys, because we really don't we don't carry the tools, and we're not allowed licensed, bonded, or insured to carry the tools, right? A lot of you are not. So what they do, guys, they have something called, for explosion-proof equipment, for my explosion-proof equipment, the boxes are ground flat to provide closed fits. You need the mating surfaces of the explosion-proof boxes are ground flat to provide closed fittings. You need these because the explosion-proof to be completely touching each other, no any niches inside it. Why? Because you don't want the gas to enter or the explosion to leave the area, the explosion-proof area. So dealing with these boxes, you go with your screwdriver and make a hole in the box or a niche in a box. You just screwed up the listing of this box. So that's a big deal. Screwdriver, guys, with deep scratches, if you have a deep scratch, can provide exit point to the hot gases. You don't want the gas to get in and the hot gas from explosion to get out, right? So you don't want to make any holes in these or niches in these boxes. All bolts must be placed in place and tight. This is mostly for electrician, workman-like manner when you go there. Long story short, what I want to summarize to you guys, if you're a project manager on a job, explosion-proof, pay a lot of attention to the actual physical installation of this job. So it's not like just a J box right there, I'm going to go put it. So you can pay a lot of attention to the workman-like manner. Seals must be installed between the explosion-proof enclosure to prevent pressure piling. If you have two explosion-proof enclosure, guys, there's a concept that's called pressure piling. I think we have a picture of it. Long story short, if you have an explosion in one enclosure and you don't have a seal, that's sealed from the other enclosure, the volume of the gas will expand rapidly, violently, and channel itself to the other explosion-proof enclosure through the conduit and create a much bigger explosion in the second enclosure. They call it pressure piling. So what do you need to do to avoid pressure piling? Between two enclosures, seal right between the two enclosures. So that's what I have, guys. I have a couple of pictures I'm going to show you. So we talked about the sealing. Here's how they do the seal. I know a lot of you guys are not in the sealing business, but you can see where the fiber dam here. They put the fiber dam, they dam the ceiling. You put your ceiling here, ceiling compound. There's a plug to put your ceiling compound. And for the most part, they have some type of drain for the equipment, and you put your cables. So the gas cannot go in any direction in these cables, and you can't pull these conductors after you seal. If you are doing horizontal crests, the way they do it, they have two dams here. Makes sense, right? Otherwise, it will see. But they bring this plug, unplug it, put the compound. Now you're sealing. Now the gas and the dust cannot go from point A to point B. The gas, mainly. Sealing compound, you plug it in there. So these are a couple of things, nice pictures. This is adapter for color, explosion-proof globe. This is how they do it, guys. They have inner colored globe and outer, so they put multiple layers around this fixture. That's how they get you the explosion-proof. So if there's an explosion inside this fixture, it wouldn't shatter and ignite the surrounding. So that's a cut view of the lamp. And Cooper, Kraus, Hinds, guys, is a major manufacturer. I'm going to show you their product in a second here. Here's an explosion-proof equipment, lighting fixtures. Explosion-proof, we talked about this one. Okay, now you're not electricians, but if you guys are project managers on a project, if you have the overload, you guys remember the overload that we did? When you do overloads in an explosion-proof, guess what you need to do? You need to go readjust the overload based on this table, if in a class 1 div 1 location. Because if you put the overload too high, the amount of energy coming out of an overload condition could ignite the surrounding. could exceed the rating of the explosion-proof equipment. So long story short, if you're installing an overload equipment controller with an overload in an explosion-proof location, class 1 div 1, you need to consult this table so you can adjust your overload condition.
And this table is supplied by the manufacturer.
Supplied by the manufacturers. Yep.
Piece has a table.
Yep. Supplied by the manufacturer. So these are a big deal in terms of adjusting it. We talked about this one, and interesting. If you have an explosion, here's an explosion-proof equipment, extra hard usage cord, you have a plug, you have explosion-proof receptacle. Anybody have seen explosion-proof receptacle? The way they do explosion-proof, guys, you can't unplug it this way. You have to first push a button here to open it. It's like a circuit breaker, and then you unplug it. Why? Because you want to interrupt in the explosion-proof receptacle. The arc is going to happen in the explosion-proof, then you unplug it. So that's how they do get the explosion-proof rating for these babies. Talked about these, talked about these, talked about these. Gas stations. This is what the mated surface, guys. You can't have any little holes here, damage to the surface, because that will leak. This one, the gas will get in, and also the explosion gas will get out. So you have to have complete mated surfaces, clean, in an explosion-proof equipment. This is a big deal. This is what they call it, guys, piling, pressure piling. So Chris, explosion-proof equipment number 1, I have an arc and spark, the gas got in, I have an explosion, right? Now what happened is that expanded gas, it will be channeled out through the conduit. You don't have an explosion here, seal here, and it goes all the way to the second one. And the explosion experts, that process create a bigger explosion in the second enclosure that the enclosure most likely will not be able to handle. So to solve this problem, pressure piling, what they do is they have a seal between the enclosures. So I have an explosion right here, guys. That explosion, the seal will seal the explosion to this enclosure. This enclosure has nothing to do with it. That's why they seal between equipment. They have arcing and sparking devices. Equipment they have arcing and sparking devices. Any comments, guys, about this? So Alaribo, every equipment that has a circuit breaker, a switch, a magnetic starter, a controller, explosion proof, you have to seal between the equipment and any other equipment. Always. What they do, you have to have, I think, 4 threads when you thread these, guys, because when you have an explosion proof, the gas will seep through the threads, and as it seeps through the threads, Chris, it will cool down. The smarter than Chad discover, that's why they use the threaded. Say you have an explosion, now that thing has the gas have to go somewhere. There's a big expansion, thermal effect, right? So that will seep right through all these threads. And by the time it goes up and down, 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 all the way, it will cool down. So that's why we use threaded in explosion-proof location. Same thing with the cables. Talk about the vents. Vents. Here's a couple of explosion-proof equipment, guys, with seals. The drainage. This is where you drain if you're putting vertically, because of any condensation. You have to drain the system. Any condensation in your system. This is a good example of a drainage, guys. So you seal this, the plug. You take this plug, you seal it right here, and this little deal here. Any condensation that turns into a water in this pipe, because it can't go all the way, it will go down here through this and seeps all the way. Either you have to unplug it, or some of them are the weeping ones. They keep, by design, every time it condensates, it just seeps through.
Does that kind of look like the explosion proof?
That's explosion proof. Yeah.
The explosion proof receptacle.
Is that what?
Is that the explosion proof receptacle?
No,
Fitting.
no, that's a fitting. That's a fitting. This is a circuit breaker, I believe. This one is my circuit breaker, based on our picture, right? This is single circuit breakers. Look at that. Does it get uglier than this? That's just a single circuit breaker. Explosion proof single circuit breaker. So here's a panel, explosion proof panel. If that's not, and if you guys look at the page 292, it says 19-11. It says This is good for a class 1 group C, D, class 2 group E, F, and G, and class 3. Manufacturers are smarter than us. They discovered they make a material that fits, not smarter, but they're part of this. They make a material that fits a lot of these specifications. Instead of splitting hair, here's one that's good for all, and color D. Another one, this one, guys, based on specification, is class 1, group C and D, class 2, group E, F, and G, and class 3. So here you go. Here's one that covers, the only thing this one is not covering is E, F, and G, C, and D, A and B. It's not covering gas A and B. That's the only thing that doesn't cover A and B. A couple of explosion, class 1, div 1. This is enclosed and cascaded luminaires. These are, Chris, we use them in a class 1 div 2 and class 2 locations. These are not explosion proof. They are what we call them enclosed and cascaded equipment. Explosion proof, here's you're looking at explosion proof piece of equipment. Explosion proof piece of equipment. Here's an explosion proof flex, I believe. This is, explosion proof flexible couplings. Class 1 A, B, C, D, class 2 group E and F and G, and class 3. There you go. Here's one piece of equipment, explosion proof flex, that you can tie it into the 3 hazardous location and all the group of the gases, all the group of the dusts, and all the fibers. Nobody's excited about that? One piece of equipment, guys. One day, when you come back to Chad, you'll be excited. This is a class 1 group C and D, a manual motor starter. Take manual motor starter. That's a push pine, like one of these. You push pine. Look at that. You're gonna go buy a big bulky things for explosion proof. Here's a push pine. Light to you. This is your push pine station. That's equivalent to what you have in the wall here in an explosion proof, though. So this boy is an explosion proof motor starter. That's your NEMA. Does it get uglier than this? So what would that give you guys an idea? Move your control and power distribution equipment away from explosion proof, because you're going to explosion class 1 div 1 location, because you're going to end up with very expensive equipment price wise and very expensive installation for this equipment. If you can't, the industry will more than happy to get you a lot of equipment. So that's my starter. Here's how they do the plug-in, Nick. We're talking about the receptacle. This is explosion-proof receptacle. Believe it or not, the room that you guys specified in a class 1 div 1 location, we did 2 receptacles per wall for a total of 8 receptacles, Phil. These receptacles must be like this. So on your plan, you should have specified that your receptacle has to be a class 1 div 1. That's all so explosion-proof. The way they do them, guys, they design it this way, where you have to interrupt the circuit before you unplug. You interrupt before you unplug. You can't unplug while energized, because that will spark, right? So first you interrupt it inside the explosion proof, and then you unplug it. Well, getting into, here's how it looks like. This is a class 1 group B, C, D, class 2 group F, G, and class 3. This plug is rated for all these locations. Cooper. This is a Cooper plug rated for all these locations. Plug and receptacle. We talked about the gases, guys. And we said A through D are class 1, E, F, and G are class 2. So that's your location. Talk about temperature rating. And that's all what I want to show you in this arena. The second thing I'm going to show you guys, take you to Cooper, and they have a manual. If anybody's interested, this is the manual that Cooper has based on 2011 that we go through our apprenticeship with. This is Cooper Crouse-Hand's 2011 Code Digest for hazardous location. Everything you need to do about hazardous location material is right in there. So I'm going to very quick, guys, walk you through. They talk here about they go through the code, they digest the code. All the articles that I just walked you guys through in an hour, they go through them step by step, and how to install in hazardous location and so forth, all this. Different pictures, the picture that you looked at is actually coming from here. So you can look at this. The one thing I want to show you, being a specifiers and engineers, is way at the bottom. I found it very interesting. Um, if you guys go to, let's just go to this one. If this picture with material catalog number from them, it will tell you the catalog number of every single fitting and every single equipment you have in a class 1. Can you guys see at the top, class 1 div 1 lighting installation? For your lighting system, every single in a class 1 div 1, every single fitting, the fitting, so you can order. So can you guys see it? So for number 1, for example, it says ceiling fittings EYS for horizontal or vertical. So if you're doing a ceiling fitting, you can go order EYS from them. That's their single fittings. Does that make sense? So if you are in the business of specifying hazardous location, this is a must-have. Must-have. So it goes all the way to the lighting fixture. So 7B, I think, is 7 fixture hanger EFHC. So all these are the different fixture hangers that you can have. Oops, there you go. So all these guys are equipments that you can use, and the reference, the NEC code reference for them. So remember the one that I told you guys about fire pump? They did the same thing with all the references of all the system. Here's a class 1 div 1 power, all the panels. So 11 is going to be breather EC. So they get you into all these equipment that you need to specify G and the section of the NEC code book that refers to it. The section of the NEC code book. So number 8 is combination circuit breaker and line starter. That's number 8. That's right here, Chris, in this area here. So anyway, without getting into all the details, and the NEC code reference. Now, if that's not enough, here's a class 1 div 2 power and lighting. Same thing, class 1 div 2. Right underneath there, they have diagram for class 2 lighting installation. Cheaper equipment. You can buy cheaper equipment for class 2 locations. And they go all through the details and all the fittings, guys. And this is my favorite, one table that gets you all the fittings for a class 1 div 1, class 2 div 2 with all the groups, and 3 with all the divisions and the groups for different things. Panel boards. If I want to specify a panel board in a class 1 div 1, Chris, it's EPL. If it's in a class 2 location, all products shown under class 2 division 1. So anyway, so that will give you tons and tons of information how to specify your material. Any question, guys, about this? This is free on the website for those of you who are going to working it. I know some of you guys might never work on hazardous location. If you ever work on hazardous, William, remember that document. Very, very interesting document that you can have. A lot of information about specification. Okay, and the last thing I want to show you is Mr. NEC code book. If you guys go to Article 500, it will, somebody, a lot of you were asking me about what the heck is a dust and fiber. If you guys go to 500, Article 500, combustible dust. In 2011, they define it as finely divided solid material with a diameter of 0.017, and if it's dissipated, it creates a fire hazard. So they get into all the details, guys, of the control of the specification. So this will it goes through the classification. Here's a class 1 location and all the stuff about class 1 location. Class 1 div 1, ignitable concentration, flammable gases, flammable liquid, produced vapors, and so forth. So it defines all these locations for you. It's a good location. It's a good article to read. And again, my intention is just to overview with you. If you guys go to 501, that will be a class. Then they go into first 500 talks about the 3 classified locations. Then 501 goes directly into class 1 location. In a class 1 location, guys, I'm going to show you what I think is an important thing. Class 1 location. So wiring methods. So you talk about wiring. If you want to know what the wiring method you can use in class 1 location, wiring method shall be complied. So you can't use any wiring method. Generally, class 1 location, the wiring methods A through G shall be threaded rigid conduit or threaded steel intermediate metal conduit. Done. That's what we've just talked about, the wiring methods. Big deal when you design. And they go through other wiring methods, guys, you can use. MI cable, and so forth. Boxes and fittings. This is where you can use explosion-proof boxes and fittings. So it goes through the seal. Where do you need to seal? Flexible connections. What type of cable you can use for flexible connection in a class 1 location. 2 or more explosion-proof enclosures, seal between them. So all this, you're going to find it right in this location here.
The term zone,
Yeah, that's right.
what is zone imply? They use it once in the book without defining.
Yeah. Zone, there are 2 classifications. There's the zone system and the division system. Think of it this way. Class 1, Zone 1, and Zone 2 as Zone 1 and Zone 2 goes with a Class 1, flammable gases. There's Zone 0, Zone 0, 1, and 2 goes with the Class 1 location. Then there's Zone 22 and 22, another zone that goes with a class 2 location. Long story short, there are 2 ways of classification, either based on the zone or based on the division. The zone is mostly, my understanding is European system, so they classify equipment based on the zone if it's European system. The code talks about the zone, guys, in a couple of chapters. So all what you need to know is Zone 1 is associated with a Class 1, flammable gases. Okay, so that's then you guys go to Class 2 location. Class 2 location, the same thing. It talks about the zone equipment. Here's the zone equipment, Chris. In 2011, they say here's the zone. If you have a zone 20 and zone 20, 21 and zone 20 goes with a Class 2 location. Div 1. Zone 21 and 22 goes with a Class 2 location, Div 2. So another classification system. Okay, so it goes through the bonding and grounding, guys, and all this good stuff that you can find there. Equipment. So if you read through it, and the last thing I want to show you is Class 3 locations. For example, in a Class 3 location, wiring method, Division 1. What can you use in a Class 3 location? Rigid metal conduit, PVC, RTRC, intermediate, EMT. Can I use an EMT in a Class 3 location? Bring it on. Div 1. MC cable, MI cable. That's a relaxed wiring methods in Class 3 location. So anyway, if you are into this business, the most important thing here is the wiring methods in that particular location. So it talks about the wiring methods and so forth. And then intrinsically safe system, Chris, talks about intrinsically safe system, drain energy system. And just because you said it, Chris, I'm going to go to the zone. Here's the zone. Article 505 talks about zone 0, 1, 2, zone 0, 1, and 1, 2 location. 0, 1, and 2, guys, go with the Class 1 location. 0 is the worst of the worst. Based on the zone 0, you cannot install anything in zone 0. I think other than intrinsically safe system. That's the only thing. Zone 1 is equivalent to Division 1. Zone 2 is equivalent to Division 2. If I remember right, I'm going out of memory here. So that's classification and the equipment that you can use in these locations. Equipment that you can use and use in these locations. Zone. And the second one, Chris, just because you open your mouth and you talk about zones, zone 20, 21, and 22, this is for combustible dust or ignitable fibers. So 20, 21, and 2 goes with a Class 2 and Class 3. Usually 20, guys, goes with Div 1, 21 and 22 goes with Div 2, Class 2 and Class 3. So the area in the US, we use the division methods, but in other parts of the world, they use the zone system, zone classification. Either way, the code will tell you guys if the equipment are rated for a Class 1 zone, zone 1 and 2, that will be Class 1 Div 1. And if it's rated for a Class 2 zone 20, that will be Class 2 Div 1, zone 21, 22, Class 2 Div 2. Any comments, any questions? Any comments, any questions? A lot? As I said, guys, what we do when we do our apprenticeship, when we train the apprenticeship, this is a 12-hour topic that you go into details into all the wiring methods and so forth. Since most of you or almost all of you will not be doing the wiring, and you have to be an engineer, we showed you what you need to know. The rest is catch with it. Every time you hear the word hazard, always think, oops, I can't use EMT and MC cable like we do in any other location. I have to pay attention to the wiring methods. So Rob, the only thing you need to know with all these details, being non-electricians, is if I'm in a classified location, two things. Number one, my equipment will be expensive and will be different type of equipment. And number two, my wiring methods will be also expensive, will be different type of wiring methods. That's the only thing you need to worry about um, in terms of specification. If you are an estimator project manager, you're going to add, and you're doing in hazardous location, you're talking about 50% extra in the labor and material for these, at least for these locations. For the same brand circuit, guys, you put it in a hazardous location or non-hazardous location class 1, it could be twice as hard and twice as expensive to do the same brand circuit or the same magnetic starter or VFD or so forth. Any question for your friend Chad?